Hello class. For this week's discussion, we have been tasked with making a video reviewing a problem from the past homework assignments. For my video, I decided to do problem 6 from our webwork homework assignment number 9, the differentials and gradients homework. For this problem, we are looking to work on the chain rule. We're going to be finding dz over dt using the chain rule. We're going to assume the variables are restricted to domains on which the functions are defined. We are given z, x, and y functions, and to start the problem we have to know our chain rule formula, which I have written out right here. So to start, we need to find our partial derivatives and derivatives of the x and y. So for z, taking the partial derivative of this equation for x, we'll get e to the y power, and then taking the partial derivative of the equation for y, we'll get 1 plus x plus y times e to the y power. Next, we're going to want to find our derivative of x and y equations for t. For x, take the derivative of 3t, we're going to get 3. Take the derivative of the y equation, 5 minus t squared, we're going to get negative 2t. Now we move on to plugging them into the chain rule equation formula. First off, we bring our e to the y power down, our 3 down for our partial derivative of x and derivative of t, and then we bring our 1 plus x plus y times e to the y power down with our negative 2t, and we're going to add these two parts. Once we get this equation, we can then plug in, or once we simplify this down as much as possible, we can then plug in our x and y values to get the whole equation into terms of t, which brings us down to our last step of plugging them in and simplifying the equation. I've already simplified and made it as simple as I can make it, so we'll end up getting 3 times e to the 5 minus t to the squared power minus 1 plus 3t plus 5 minus t squared times e to the 5 minus 2t power all times 2t. And that is our simplest answer that we can get for this problem. Other problems might be a little bit simpler or a little bit longer, but for this problem, this is what you end up getting. That is all, and I hope you all have a wonderful week.